Assalamu alaikum. In the name of God, the compassionate, the merciful, welcome to this session of software testing. I'm sorry for previous session which I couldn't hold at Saturday. I wanted to prepare a recording, but I like to do the first session which I explained the J unit online, but in the next session we provide, before next session we provide a recording about the J unit, about the next second part of the unit. We want to explain J unit, how to use J unit in 2 sessions. The first session is this session online, and the next one could be offline, could be done offline, and I prepare a recording for you. So we start our talking. Let me record the meeting and share our slides. Okay. Have you heard me? Do you see my screen? No problem. Sound is not clear. Yes, this is chapter 3. But before I explain the main slide, our main slides, or the slides of Professor Jeff Offwood, we use some other slides to explain how to use J unit, and next we return to our main slides. Yes, this is about test automation. Let me to start the talking. How to test a software? How we want to test software? The testing of software, as I said in previous lectures, could be done by manually, could be done manually, could be done by using test tools and test codes, and could be done by the programmer or test team. But there is some problem when we try to do the test manually. The test should be discarded after testing, and test is not reusable. Tests should be executed by hand, and it's very time consuming, and so on. But, so there are a lot of disadvantages in doing testing manually. To deal with these disadvantages, we use some testing tools in software testing industry. There are some test tools for testing, for doing performance test, profiling, load test, and so on. But in this section, we focus on unit testing. As you know, unit testing is done by the programmer who implement the functionalities of our software under test, try to test his code, his business code himself, and usually the unit code is done by developer, not by a test team. In a unit test, we try to test the functionality of our units, not the performance or load test or security testing. We just in unit testing, we just try to test the functionality of our methods or our classes that we implement in some programming language. For doing unit test, we use test code. Could be written in some frameworks such as JUnit, CPP-Unit, and so on. In this session, we talk about how to use JUnit, how we implement our test codes, how we write our test codes in JUnit infrastructure. When we do a unit test, we have to separate set of codes. Includes the business code and the test code. What's the business code? The business code is the code written for implementation of a requirement, which provides the functionality of our software, our product. The code which implements our classes, our methods of the main program or main product. But the test code is a code that's written for testing a business code. We write the test code to test the business code or test the implementation of the product. So we differentiate these two code. The business code and test code is a separate programming code, as we will see soon. In excuse me, my connection was lost for a moment. Do you hear me? Do you have sound? Yes, okay. Let me share. My connection was lost again. At this time it is okay. Let me share my screen. excuse me. So we have to separate piece of code in our project, named the business code and test code, as I explained for you. And as I said, in unit testing is a process for a programmer to write unit tests, which tests methods and classes of our program in order to improving the quality of code, in order to reduce bugs of our code or faults in our code. And test of units of software should be done before the software is completed. In unit testing, as I said, we focus on testing the functionality of our methods and our classes in the project under test or program under test. So as we program some problem, we write a main method to start the execution of our program in classical unit testing. This means that when we want to test some of the implemented methods of a specific class, we prepare a main method for that class, or in another class to call the methods which we want to test, and we use the console to write the result of the execution, the actual result of the execution, and check the results manually, and we can check by eye to determine if the test is failed or passed. So in classical unit testing, we use some print lines instruction to write the result of our results of our methods under test in the console to allow the programmer or the user to see the actual result and check the correctness of the actual result. This means that in classical or traditional unit testing, we, for example, for testing a sort method, we provide a main method in some class, in a specific class, and we provide a list for send to the method, the sort method, to be sorted, such as this. In this piece of code, our test data is this list. The list being 3, 2, 5, 7, 6. Excuse me. And then we call the sort method for this list. After the execution of this instruction, after the execution of this statement, the list should be sorted. So, in order to give enough confidence about the sorted list, we should print out the sorted form of the list and check the correctness of the sorting. For this aim, we use a for loop to print out the elements of the list. So in this for loop, we use the statement of print line to print each element of the list, and as you Excuse me, my connection was lost again. This is because my poor infrastructure. In which slide the connection was lost? Can you tell me? I've explained this slide and this slide, but I repeat this again. Let me share. Could you hear me? Yes. Excuse me again. I changed my connection, and I hope we could done the lecture with no problem. It's better. Okay. As I said, in traditional or classical unit testing, for example, to test some methods such as a sort method, we should prepare a main function in a specific class and call the sort method by some input and check the result of the sorting method after the execution of the statement, of the sorted statement. So in this example you could see that for testing a sort we have provided a list such as this, and we call the sort method for this list. After this we try to print out the elements of list one by one to check the programmer with the aim of checking the correctness of the sorted list. As you know, because of the print out statements is located after the sort function, we should see the sorted list, and as you see this is correct in this case because the elements print out one by one is in a sorted form. This method, this traditional testing has some drawbacks. Could you tell me what are the drawbacks of this traditional testing method? Could you guess the drawbacks of this testing method, in which we should provide a main function and call the methods and write or print out the results of the method so that the programmer could check the correctness of the actual result and generate reports about the failing or passing the test. What are the drawbacks of this method? Could you tell me? Excuse me again, today we hold 3 sessions, but in this later session our infrastructure is very poor and my connection was lost again. Excuse me, I changed my connection to another network. I think the internet is very poor at this time in our city. If my connection losses new time, we postponed the section to take a recording for you. I start the lecture again, but if it interrupts, I try to take a record tonight. Do you have you sound? Yes. Let's keep going. But if it drops again, we finish the lecture and take a record tonight. We talked about the drawbacks of traditional testing. The main drawbacks of traditional testing is listed in this slide. The first drawback is that in traditional testing we should couple the test code with the business code. As you know, in business code we need the method main for other purposes, and when we use the main method for testing some methods or some classes, we have to clean our test code soon and use the main method for ordinary using. This is one of the drawbacks of the traditional testing method. The next one is that the written tests are discarded. As you know, let me to take a record tonight and send you. Excuse me for these interruptions. Okay. If you had a question, if you have question, please ask your questions, and I try to answer your questions if my connection helped me. Thank you for your attendance and attending to the session. I hope I have a next session better, with better connection and with better quality. And see you next session. Excuse me, we have a question. We want to know something about the exam, about the questions, for example, about the nature of the exam. As I said in the first session, your exam, your final evaluation has 4 parts. One of them is your study project and your presentation, and probably your implementation of study project. And some parts is about the materials of the course, such as our materials presented in previous slides. And in this chapter we teach you how to use JUnit. You should do some exercises, and soon you will be familiar with the exercises about how to writing test scripts, how to generating test data in next session, how to use some coverage criteria in chapters 7, 8, and 9, 6, 7, and 8, and 9, and you will be familiar with the nature of the questions in these two first chapter. We just talked about some principles about software testing, and we have not notable exercises. But at this session, your exercises will be start, and you can do your exercises more mathematically, and I hope there are no problem in doing your exercises. So let me to prepare some recording for you about this session, and in next session at Saturday, we will answer more your questions about your exercises in J unit, for example. Okay. No problem. I think my connection was lost just for my presentation, and in this talking, in answering your question, it is okay. If you want, we can try another time. I try again to presenting my lecture if possible. I hope it is not interrupted again. Let me test again. Excuse me. As I said about drawbacks of the traditional unit, the unit tests should be discarded soon, and it's a notable drawback because our test could not be reusable, and we should rewrite tests for several times when we change the functionality of our program, when we add some abilities to our program, or when we debug the method for a method for several times. We should write test codes again and again and again, and this is a notable drawback of traditional testing. Another drawback of traditional testing, in which we test the method in main method, is that we can just do one test at a time. At the same time, we just can test one method, and we could not test more than one method simultaneously. So this is another drawback of the traditional method of unit testing. And the another one is that the programmer executes the tests himself. The test execution is not automatic. This is another drawback, and this could be could have a cost for the tester and very time consuming. The other drawback is that the programmer should check the results of each test himself, and this could be very error prone, because the programmer maybe calculate the results incorrect, or when he done eye check, he would be make a mistake in a comparison of the expected result with actual result. So the programmer should summarize that the test is passed or failed manually and generate a report for the for himself about the test result interpretation is not automatic. Okay, so we summarize the drawbacks of the traditional testing in this slide as 5 points. As you know, the first one is that the test code mixed with the business code. The test codes are discarded. At the same time, we could not test more than one method. The programmer should execute the test code himself, and the programmer should summarize the result of testing manually. And as I said, this could be very error prone. So we need a better unit testing method. What is what's a good unit test method or unit test code? I need a unit test code that could be repeatable and reusable for several times. Or I need a test code that could be run automatically and could be summarized the results of the testing automatically. The test code should invoke the methods, the business method automatically, and summarize the failure or passing of the method automatically. In this content, with these aims, we could use JUnit infrastructure to write unit testing for Java programs or integration testing. We also could do the integration testing by JUnit infrastructure. Let me to explain a simple test code in JUnit practically. So we use the Eclipse environment, Eclipse IDE to write our test codes in this session. Suppose we have a simple program which has just a class, the calculation class, and in this class we just have a simple method, the add method, which has two parameters, a and b of type integer, and in the body of this method we calculate the summation of a and b and return the sum of a plus b. This is just a simple method, and we want to know how to write a test code for this simple class in JUnit. This is my first project in JUnit, which is written by Java programming language. For testing this class, we provide a test class. We name this class as calculation test, and we write a test method which we want to test the addition method of our business class. The calculation class, the calc class, is our business class, and this class is our test class. In the test class, we write our test method. Our test methods in JUnit should be started with the annotation @test, and usually we name the test method according to the business method, in which in the business class we have a method add. So when we want to write a test method for this method, we name the test method by test add. In JUnit test cases, we could use some assertions such as assert true, assert equal, assert false, assert null, and so on, which I will explain for you soon. In assert true method, the JUnit try to call the add method of the calculation class of our business class by some input data. This method is called, and the actual result of executing of this method would be compared with the expected result. As you know, the expected result of the summation of 2 and 3 should be 5. Our expected result is 5 for summation of 2 and 3, and the actual result is the result which is returned by the execution of the add method of our business class. This is the business class, and this is a test class. Okay, we run this test method by this icon in Eclipse, and you could see the result of our test method. In this test class, we just have one test method, and the JUnit infrastructure, JUnit framework, run this test, and as you see in our report, there is no errors and no failures in this test method. So this test method was passed. But for example, suppose we provide an incorrect expected result. As you see, we change the expected result to 6. And we try again to run this test method, and I expected that this test would be failed. Let me see. As you see, we have one failure. Which test method failed? I could click this icon to show me which assertion failed in this testing. So this is just a simple using of JUnit to test a simple method. In practice, you don't need to test this simple method, but this is just for explanation by simple example. As another example, let me explain our slides, the examples showed in our slides. Before this, let me see your comments. Let me explain later about this message about the exercises and exam. Write something about the exam. Okay, I will introduce you in the group, and I would take a midterm exam for just to be familiar with our exam at the final, not for evaluation. Let me do this later. As another example, we return to the sort example, as we saw in classical method. In the classical method, as I said, we write a test code which could be run manually and should be discarded soon. And some other drawbacks, as I said for you in previous slides. So we do this example by JUnit. Please note to this example again. If we want to test the sort method in JUnit, we should provide a test method such as test sort. In this example, we define a business test class. As you know, our test class should include a business method which named sort to sort some lists of integer. So doing test automatically, we provide a test method in our business test class such as this. In this method, we define a simple list of integer elements, and we call the business sort method the sort method of our business class with parameter list with this parameter, and after the calling of this method, we should compare the sorted copy of this list with the result of this method. As you know, the result of this method are showed in the order of the elements of the list. So after the sorting, we provide the expected result. This is our expected result. We expected that the sort method sort this list by this order. Okay. Next, we should compare one by one the elements of the sorted list with the list. If they are sorted in the same order, we say that the sort passed the list and the test was done successfully. But if the order is not the same, we summarize that the result of the testing is failure. Okay. For this matter, we should use a for loop to compare elements of the list and the sorted version of the list one by one by assert equal method. The assert equal method checks the equality of these two parameters, and if they are the same, there is no problem. But if they are different, the assert equal report failure and announce the user or tester to this failure. Okay, we could examine this method again in JUnit or in Eclipse. For this example, I define a new project in Eclipse so that you could be familiar with using Eclipse. We define a Java project. The name of our project could be some strings such as sorting project, sorting project, capital O. Okay. So I close the previous classes, and in our package explorer we see another project such as sorting project. In this project we define our business class new job by defining new Java class. We define this class as business class, and it should be included with business code. In this business class, we define a simple sort method. You can search from the web for a simple insertion method. I searched it before class, and we use this method. We copy this method. This is a simple insertion sort method, and we use this method in our project. So in our business class, we just have an insertion sort method which could sort any array of integer elements. To test this business method, we should define another class which is our test class. So by right click on the project, we could define a new class. We name this new class by the name of such as business test class. This is a test class. This is our test class. In this test class, we should define a test method for insertion sort. We define a public void test. The name of our test method could be insertion sort test. We have we define this method such as this method. We should provide a list we should provide an input data for our testing, for doing our test method. So we define a list, a simple list such as this, by some elements such as 4, 5, 2, 3, 7, and 1. This is a simple array which is not sorted, but by calling our business sort method, we could test this method in this test method. As I said before, our test method should be started with the annotation @ test. As you see, there is an error in this annotation. By focusing your cursor of your mouse on this annotation, you see this table which help you to fix this error. This table tell you add JUnit 4 library or add JUnit 5 library to your build path. To adding the JUnit library, you could click on this links, but another way is that you could right click on a JRE library on your project and click the configure a build path on your build path and add the library to this libraries. Select JUnit, click on next button, and you could use you could select your JUnit version. In this example, for example, we use JUnit 4. You can use JUnit 5, but for some of our examples, the JUnit 5 do not work in our experimentation. So we apply this change and close. Okay. Again, we focus on this annotation to see why this is underlined red. We should import the JUnit for business class or business test class by importing this statement. The error fixed. Let me after the definition of our input data or our list, input list, let me call the business method. Our business method is the insertion sort method from business class. So as this method is defined as a static method, we could call this method directly, and there is no need to define an object and instance of the business class. If you are familiar with the object-oriented programming, this is easy for you. So I call the insertion method such as this business class insertion sort, and the parameter is list. So by this statement we call the insertion sort of our business code, and after this we should provide an expected result for this method. As you know, the expected result for this list, for sorting this list, is the sorted form of these elements. So we define another array named by sorted array, sorted list. The sorted list could be this. The sorted order of these elements could be first of all 1, then the element 2, then 3, and 4, then the element 5, and finally the element 7. This is the sorted form of this list. We expect the output of this method be the same as this one. Okay, so for comparison this expected result with the actual result of this method, we use a for loop to comparison each of the elements one by one. But what is the actual result? Where is the actual result? Could you tell me? Could you tell me? By execution of this method, where is the actual result? How the sorted form of the elements stored in main memory? The result is stored in place in the list array. As you know, when we use an array for input parameter of our methods, this array should be this method call should be done by call by address. It's a call by address, call by reference, and any change in this method, any change in this insertion method was reflected in input array by the input array. This sort method is a in-place sorting method which sorts the elements in the same array as passed by the parameter. So the result, the actual result is stored in the list again. So we should compare the sorted list with the list. What is the list after the execution of this method call is different from the initial list. Especially the order of the elements would be different because the insertion sort changes the order of its elements. So the actual result is the sorted form of this list, which saved in place in the list array. To comparison of these two lists, we use a for loop for enter I be 0 I while I less than the least length and I plus plus. We should use an assert equal. Assert equals. As you know, we can use several assert equals method with different parameters. We used a version that accept two integers. Assert equals list, the list I element with the sorted list I. By comparison of these two elements one by one, we receive that the list is sorted correctly or not. Let me execute this test method. Our test is passed because the insertion sort method is correct. Suppose we define another expected result, an incorrect expected result, such as this. As you know, this is incorrect. The sorted form of these elements is not this, as you see. So if we executed again this test method, it should be failed. Let me see. As you see, the report provided for us show that we've run one test and we have one failure. This is because this expected result is wrong. This means that our test case is wrong. If you remember, I said in previous lectures, when our test cases fail, we should check both the test case and the business code. It's possible that there is an error in our test case for this with the same probability. This is possible that our business code would be wrong. So if we fix this and instead of this error we make we make another error in this method, such as this. We change this insertion method, and at this time this insertion method could not be true because I changed the sign of bigger than to less than. If you run the test again, the test should be failed again. As you know, you see the test failed again. But there is an important question, which is that what's the differences of this testing way with the traditional way of testing, with the traditional method of testing. As I said, in traditional method, we test the insertion method, such as this, done by this example. In traditional testing, for testing this insertion method, we should provide a main method in our business class and mix the business code and the test code together and couple these two pieces of code together, and in the main method we should provide input data or test data and use some print out instructions, some print out statement to show the how to execute how to test the business code, and after the execution, after the calling of the business method under test, we should print out some results of this method call, and we should compare the results manually. See this method. Suppose we want to test this method traditionally. In classical method test, we should define a main method in a class, and we could run this main method such as this. As you know, in this main method we provided an input, the test data. This is our test data, and we announce to the user, we print out our test data before calling of insertion sort, and then after the calling of insertion sort, we again print out the list of our element or the sorted form of our element, as you see in the console tab of our IDE. So by executing this main method, we should compare the expected result with the actual result. This is actual result, and we should check this manually. This method could not be executed automatically. What means this sentence? We could have several tests in this test class, and we could test them simultaneously. For example, we could have another test case such as this, at sign test. We could have another test method, public void find max. Find max. We want to find the maximum of this array. Okay. If we have another test method in our business class for finding the maximum of the array or finding the minimum of array, we could write a test code in the same class for testing the find max or find max test, and write another test method for find mean, for example. Find mean. Okay, and in this method, in this approach, we could run all of our test cases at the same time. We can run these test cases together and run them automatically. And there is no need to check the expected result, to compare the expected result by the actual result one by one manually, and this could be do again for the next test method and next test method and so on. So the using of this framework could be very simpler than we should done in traditional method. Okay, if we clear this method, we can clear this method, and we could write a method for find mean and find max, public static void find void the find of a list to be integer, find max, which we want to find the maximum element of its parameter. Its parameter could be a list or an array of integer. You can complete this method and do again for find mean. Find max and find mean. For finding the maximum number of the element, we define int max and set the first element of array 0, and then we use a for loop to compare any other elements by the max value int I from 1 to I less than array with length I plus plus. In this for loop, if we encounter with a bigger element, we should change the max value. If max is less than the array the array I, then we change marks to the new element array I. Okay, and this is I++. And finally we should return the max value. This is a method for finding a maximum element of an array, and we could write the same one for finding minimum. We change this variable to mean, and this one these two variables. Okay, the main difference is that in this if statement we should search for an element with the least value, the minimum element. We should change this operator to the greater than. If see an element which is less than the minimum, the current minimum value, we should change the mean value to the new element. So in our business test class, we could provide another test method. We could call we could define the actual max as the calling of business find max or input array. We define data as global, so we cut this line and we paste this location. So we call the find max from the business class for this array. Find max list. The actual result of calling the find max method of the business class is stored in this variable actual maximum. But as you know, the expected result, we expect the maximum of this element be 7, the 7 element. Okay. So we define expected result expected max to be 7, and the assertion we could use to compare these two values, expected value and actual value, we should use assert equal the expected max with actual max. If these two values are the same, the test method will pass. But if this is these are different, the test method will be failed. We can do the same for the next method. Okay, but in this case we define actual mean with expected mean. The minimum number of the list is 1, not 7. Okay, and we should call the find mean instead of find max. Then we compare the actual mean with the expected mean. Okay, this mean should be written. Okay, so in this test class, at this time we have 3 test methods. We have 3 test methods, and I want to put them all together to execute them at the same time automatically. I don't want to correctness of them by hand or by eye checking. So if we run this test class, the report that is provided for me say that the 3 test cases have been run, and there is no error and failures in these test cases. For example, if we change our expected max incorrectly to, for example, 4, this test method should be failed, and this should be showed in our report automatically. Okay, if I execute it again, as you see, we have run 3 test cases for 3 test methods, but we have 1 failure. Which one of these test cases was failed? As you see in this report, you perceive that this one is wrong. This one is wrong. Which is this one? This is the find max method, and the assertion that check the equivalency of the equality of these 2 parameters failed. As I check the correctness of our test case or our business method, first of all we check the business method. We see that the business method is okay. There is no error in this business method. But when we check the test method, we see that we define the expected result incorrect. Expected result should be 7, not 4. As you saw, by using of this framework, by using of this method of testing, there is no need to check the result of the testing manually, or execute the test one by one, and the execution of them manually, execute them manually. but all of our test cases could be run at the same time automatically, and the results of our test and reports could be generated automatically. So this is very important. I hope that my explanation would be proper for you. I try to explain with more details in our recording so that you could write your own test methods in JUnit. If you are not familiar with Eclipse IDE or Java programming, please try because there is a serious problem in learning Java program. This is its syntax is the same as C++ and other object-oriented programming languages such as C#, and there is no serious differences in its syntax, so you could write a simple method and you could provide some simple test methods. In the next lecture we explain more examples to using the JUnit platform for JUnit framework for doing unit testing. Question, you could ask your question. If you have no question, let me finish the session. Thank you for your attention, and excuse me for the interruptions caused by our connection. Okay. Good night, and see you later. Okay, I will explain more examples in our recording that I will take probably before the next session. Okay, في أمان الله, and have a nice days.